Alright, today we're talking the basics of electricity, and we're still kind of getting to know what this stuff is before we get to use it and all that. So we're just going to take a little bit to kind of get the background stuff that's going to help us throughout the rest of the course. So what I'd like you to do today is make sure you're taking notes. Get out a piece of paper and a pencil, have that in front of you. And if I tell you to take a note, just go ahead and pause the video, jot that down quick before you move on. Okay? The very first thing you want to write is the title here, Basics of Electricity. So go ahead and put that at the top of your page. And remember, these can be used, these notes, on our first quiz. Okay, so what is electricity? It involves the movement of electrons. We know that now. It is invisible. And I bet you if you think about it hard, think about lightning or a taser or the shock that you get when you rub your socks on the carpet, you might be able to say, no, it's not. Well, that's a special circumstance. Typically, yes, electricity is invisible, but sometimes it's not getting all used up. It does find a way to use itself up, like creating noise or heat or light, okay? And that's exactly what it's intended for. It wants to do four things: light, heat, sound, or motion, okay? We've been using it for around the last 100 years in the world. Okay, let's keep going. 2,500 years ago, the Greeks rubbed amber with other materials, and they found out that this would attract the feathers and other lightweight materials to the amber. Okay, so they would rub this stuff together and figured out, all right, there's some sort of connection going on here, and they had to figure out what it was. Well, over the generations that passed, we definitely got a little bit more information on what electricity was, and soon there was these guys like Benjamin Franklin who came along and suggested that, hey, this electricity stuff, that's what's the root of that whole feather amber deal, and it has these charges, okay, and I'm going to say that opposite charges attract and like charges repel. So here's an example: opposites attract and likes repel. Now think for a second, what does that sound like? Well, if it sounds like magnets, you are exactly correct, and there's actually a good connection between magnets and electricity. Okay, so that's the law of charges. We can kind of skip past that. And this is one from last week where we were talking about, hey, that electron flow. That's one electron comes in, knocks that other electron off to the next atom, and it's just chain reaction. So that's kind of our background. Okay, let's start in on the stuff for today. Here's where the notes begin. What makes up an electric circuit? Well, we're going to start building electric circuits and actually get to play a little bit with electricity. But we need to know some stuff. First of all, there's four parts of a circuit, and we need to know that. There's also three parts of electricity, and we need to know those. So go ahead and pause whenever you need to and write this down as well as this, and I will explain what's going on here after you unpause. Okay, so our four parts of a circuit. We have the supply, which is your battery or wherever the electricity is coming from. You've got the path, which is your wiring. You've got a switch, which turns it on and off. And then you have a load of some kind, whatever is actually using up that electricity. So, for example, you could have a light bulb. And this, what you see here, these four parts, this is a basic flashlight. If you think about it, there's only four things a flashlight has. It has a battery, it has some wiring, it has a switch to turn off and on, and it has a light bulb. Okay, so that's a flashlight circuit. There's also these three parts of electricity: voltage, current, and resistance. And we're going to learn about these specifically today, but we're going to have to know these things in order to really take a closer look at these. Okay, now today when we're learning those three parts of electricity, we're going to use water to kind of figure out what's going on. Okay, so a lot of our examples will have this picture, and you have a tank here, and that kind of reminds you of a battery, or that's what we're going to pretend is our battery, where all the electricity or water is stored. A pipe is going to be like the wiring. It's what lets the water or electricity travel. Okay, and then we've got a faucet like a switch. It's what turns on and off the electricity or water. Okay, so here's our first thing. We've got this first part of electricity called current. Go ahead and write that down and write down the definition. It's the flow of electric charge. Current is measured in amps, okay, which are abbreviated as A. Okay, so when we measure current, it's in something called amps, and the abbreviation is A. So this is the flow of electric charge. So when the faucet or switch is off, is there any flow? No, there's not. But when you turn it on, is there flow? Yes. Okay, so that's why current is the flow of electric charge. Okay, current in a circuit. Okay, when the switch is off, no current. When it's on, there is current. Okay, so it's the flow. Next thing is voltage. Go ahead and write that down. It's the force or pressure. That pressure word is huge. Behind the flow of current. Okay, it's measured in volts, which are abbreviated as V. It's a force or pressure behind the flow of current, so it's what's pushing that current along. The next question is, when the faucet or switch is off, is there any pressure? Is the water still trying to push up against that faucet or against the sides of the pipe or the tank? Yeah, it's pushing everywhere. It wants to get out. It just can't. Okay, so yes, there's always pressure. All right, and that's the same in a circuit. Even when the switch is off, there's still pressure trying to get through. It just can't. Okay, when the faucet is on, is there any pressure? Yeah, that's what's making the current move. Okay, that's what's pushing the electricity through the circuit or the water through the system. Okay, same thing here. The battery provides the voltage that will push that electricity through the bulb when the switch is on. All right, third one, resistance. Go ahead and write that down. Resistance is your opposition to the flow of current. Okay, so it's something that opposes the flow. It's measured in ohms. And it's got this omega symbol here. Okay. So, our analogy says, what happens to the flow or current if a rock gets lodged in the pipe? So let's watch our rock fall in. Well, we're going to see our water or our flow decreases. A lot of people think stop immediately. In this case, a little water is still getting by. Okay, and that's to represent resistance. It doesn't necessarily always stop the electricity. It just slows it down sometimes. Okay, so same thing here. There's a thing called a resistor, and it's a component that limits the flow of electricity. We can put those into our circuits like this and actually slow down the electricity, and it'll make your light bulb a lot more dim. Okay? Alright, let's keep going. We're almost done. We've got a couple types of electricity. There's static and current. You don't have to write down anything about either of those, but I do need you to know there's two types of electricity, static and current. Static and current. Okay, static is the stuff that's wild. It's in nature. It's not tamed. Current is what's in a circuit. It's controlled electricity. Static is lightning, the shock that you get when you rub your socks against the carpet, or in some cases, depending on your pants, people can rub their butts on the chairs and they can get a shock by touching something metal. Okay? Current is what you would have inside of your cell phone, what's inside of your computer right now. So that's what's going on there. Okay, we can kind of skip past this, but I'll let you take a peek for a second. Current electricity, there's two types of that, and we need to know this as well. Okay? Current electricity, there's two specific types. There is direct current, or DC electricity, and there's alternating current, or AC electricity. So please get those down. Okay, fun fact, if you've ever heard of the band AC/DC, they got their name from looking at the back of a vacuum cleaner where it said AC/DC vacuum. Alright, so direct current, what's going on? Well, basically just says the current flows in one direction. That's not the super important part. What is knowing this symbol. Okay? So somewhere near direct current, please write down this symbol. Very important that you know the three lines with, the line with the 3 dashes underneath. That means DC. Okay, direct current's anything that comes with batteries. Okay, it gets converted from alternating current. So computers, iPods, cell phones, anything that has a charger is going to use direct current. So that would make sense then that alternating current is anything that's from the wall. Okay, and the current changes direction. It goes back and forth and back and forth. And that's not super important to us either, but what is knowing the symbol. Okay, we want to know the difference in the symbols at least so we can properly switch on our meters or whatever we're doing. We want to be able to locate whether we're on DC or AC. Okay, so here's an example. Current goes one way, then back the other, then one way, then back the other. Okay, alright, your alternating current comes from generators. It's what's in your walls. It's used for motors, heaters, lights, anything that plugs into your wall. Okay, so that's that. The big stuff we got notes on. I'm sorry if that was a little bit long. We're going to get into some wood shop stuff pretty soon and starting on some circuit building soon. So all this is important background knowledge that we need in order to kind of move along and get to the really fun stuff. So good job taking down notes. At this point, I should have told you what the next step is, so go ahead and do that.